Okay, question 2. Find a complete set of values of p for which the equation x squared minus 2px plus y squared minus 6y blah blah describes a circle in the xy plane. Okay, so what are some conditions for an equation to describe a circle in the xy plane? So if we consider the general form for a circle, as in this one, when you have the center and the radius, so you're going to make sure that the r squared is greater, well, strictly greater, I suppose, strictly greater than 0, right? Because if you have radius 0, then you can't really, it doesn't really work. And of course, if r squared is less than 0, then that's even worse, right? You don't even have a proper r, yeah? Okay, so I'm going to make sure that r squared is strictly greater than 0. This is my condition. Yeah. Okay, but then, before I try to apply this condition, I'm going to make sure that I change the original equation into this form, right? Into this x minus a squared plus y minus b squared equals r squared, sort of Pythagoras form in some way. All right, so what would I do? Okay, using that equation, the classic technique here is to complete the square. Yeah, very, very classic technique. So off we go. So x minus, you divide the coefficient by 2, right? So x minus p all squared, all right, minus b squared to compensate, plus, same thing, y minus 3 squared, again, minus 3 squared to compensate, minus p squared plus 8p plus 9 equals to 0. Happy so far. All right, okay, so this simplifies into what? Let me scroll down a bit just for the sake of space. I hope I could scroll down. There we go. Okay, so if I rearrange this a bit, then x minus p squared plus y minus 3 squared equals what? So I'm going to chuck everything else to the right-hand side, right? Because everything else on the right-hand side would be r squared. Yeah, would be r squared. So now I have 2p squared. Okay, the 3 squared and the 9 cancels. So 2p squared minus 8p. All right, so now we have 2p squared minus 8p must be strictly greater than 0. Now, technically, you could go like greater or equal to, because if you want radius equal to 0 be a circle, then I mean, fine. But, let's say it's just strictly greater than 0. All right, okay, now this solves into p, brackets p minus 4 is greater than 0. Okay, so how do we solve quadratic inequalities? Well, for me, I draw a graph. All right, so p and p minus 4, so it's going here and here. Graph, 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 graph. Okay, it's greater than 0, right? If it's greater than 0, then it must be talking about the outside, all right? The outside of things. So if I chop this into 3 parts, these parts are what I'm interested in. Yeah, those are the parts where the quadratic is greater than 0. Cool, so it's the outside. So therefore, p is less than 0 for the left-hand side, yeah, because that's 0. And then for the right-hand side, p is greater than 4, because the other boundary is 4. All right, so the answer is, let me see, looks like D to me. All right, make sure don't pick B. Yeah, B is the inside. All right, so the answer is D.